well, I can hear you when you are doing something together, which is very good. And I cannot see you very much because of the lights, but that is a minor point. Thank you for coming to the session. My name is Oleg Šelajev. We're going to talk about developer productivity. We're going to talk about tests. We're going to talk about how you can do test setups. And we're going to finish with a little demo of a project that has some tests and local environment setup using test containers on a Spring Boot application example. So the title of the session, of course, is from the wonderful movie Pulp Fiction from the 1994. So it's a little bit older than Java, interestingly enough. But it's a great, just like Java, it's a great piece of art nonetheless. So let's talk about developer productivity first. It's a very important metric, and it's something that is very hard to measure. We all have sort of intuitive understanding of when we are productive. We have sort of intuitive understanding when we are not productive, when like work feels like a chore, like things don't move, features are not being developed, and every step of the progress feels like you are just going through mud and you are stuck in it. However, it's a very soft feeling, and if you look at this from the organization point of view, you look at that like what can you improve in the process, and it's really, really hard to operate when you are talking only about soft feedback items, like maybe surveys or maybe questions about developer happiness, because they are, well, essentially soft, right? So look, there are no particular metrics what to measure, so it's a hard topic. Now, still, people are trying to research this and make advancements, and there was a really recent paper from some researchers based both on universities and Microsoft Research, and they run their research, they run their surveys, they looked at how previous teams organize and define productivity, and they sort of distilled various factors about productivity into 3 core dimensions of what makes a good developer experience and what makes high-performing teams different from low-performing teams. And there are 3 things which the core dimensions of developer experience. Those are the feedback loops, the cognitive load, and the flow state. For some reason, they also illustrated this with a triangle like this, which is a little bit awkward because it feels, from the image, it feels like you only can choose like sort of 2 of them. You can never achieve like good results on all 3 metrics, which is not true. So it's more like a 3-dimensional like cube rather than the triangle where you pick choices. It's an interesting paper, but in a nutshell, it talks about 3 things which improve developer experience, which improve developer happiness, and thus improve productivity, assuming that developers want to be productive in the first place. So the first one is feedback loops. Feedback loops are how fast we get like some information for our actions and about like whether we are doing the right thing, whether the thing that we are doing are of acceptable quality. And this is your test results. This is the results of your CI runs. This is the results of your work of the QA team, if you have such in the process. This is also small things, well, not small things, other things that are not directly related to the running tests or verifying the quality of the code, but for example, code reviews, which also provide you with feedback whether you can move forward in your development process. So, and slow feedback loops obviously make things inefficient. As a developer, you will need to wait for the results and waste time waiting for the results. And also, this is one way how feedback loops can be bad, like just being slow. And the other one, they can be insignificant. If your code review, for example, happens mostly for the checkbox to pass the process, then it doesn't give you a lot of information, and you mostly just ignore, or like the code reviewer also ignores the merits of the code and just like do a superficial review. This is also very, very bad because it makes your process inefficient. It makes your process have busy work steps that actually stall the progress but don't bring enough value. So that makes developers unhappy. That makes you inefficient because everything starts feeling like a chore, something that you need to do, but you actually don't want to do because it doesn't make you happier. Right? So feedback flows should be fast and hopefully very significant. Cognitive load and how it relates to developer productivity and happiness. Cognitive load encompasses the amount of mental processing power required to perform certain tasks. When you develop applications, or when you fix bugs, or when you change code in any way, you need to mainly answer 3 questions, right? You need to answer, what does a particular piece of code do? You need to answer, why does it do it this way? So not just what it does, but like what were the reasons for it to be implemented this way? And then how do you implement it in a different way that adds your business logic that you need, or fixes an issue, or something like this? So you need to find the place where you need to change the code. You need to change it in a specific way. And then you need to sort of understand the previous state, not to break it in an unexpected ways. So what you want to have low cognitive load. You want to have all the tools in your development process help you reduce cognitive load. Because the more information you need to keep in your head, the more inefficient you will be. Any small interruptions will require longer times to get into the understanding what the code does. The inefficient documentation or inefficient information about the history of the project, how it became to be, and what exactly it does in every small component will lead you to waste time on finding the places where you need to change code, and also would lead you to your changes breaking other people's work. So that is inefficient. You want to reduce the cognitive load. And there is something that's called the flow state, or colloquially referred to as being in the zone, which is a mental state where you as a person are performing at the peak activity. You're fully immersed in something that you are doing. So if you were developing something, you were just having fun doing things, and it feels like you're making progress. It feels like you are being efficient, and it also allows you to achieve like lots of progress in the minimal time. There are a number of factors that help with being in the flow. Obviously, no interruptions is like the most natural one, right? If you have meetings where you need to go somewhere every hour, then probably you will not achieve any flow state or deep work time. But there are other factors as well, which is the autonomy over what you're actually doing and your work structure, having the clear responsibilities and the clear understanding of the progress that you're making and the goals. All that helps you achieve the flow much, much easier. And achieve the flow much, much easier. And help you work on even the more challenging tasks. So those 3 things are essential to developer productivity. And today I'm going to argue that all 3 of them can be greatly improved by having better tests. And unless you have better tests or good tests, you will not achieve great results on either of 3 metrics here. My name is Oleg Šelajev. I work as a developer relations person at Atomic Jar. Atomic Jar is a startup made by the test containers libraries maintainers. We build tools and libraries that help you test your applications better. We try to shift testing left into the development pipeline. And so far, we are doing pretty well. We're going to talk about the test containers libraries. They're very popular. They're very popular in different ecosystems. In the Java, probably the most. And we also offer services to help you run your test containers tests, which we're going to see as well. So let's talk about tests and why they're essential for developer productivity. Well, the answer to that is very, very simple. First of all, they sit on the path from development to production, so you cannot avoid them. There is, whether you actually practice like sort of DevOps or whether you are working in a more traditional work environment where we have a development team and you have the operations team and you have maybe a QA team and you develop luckily, happily your application and you sort of throw it over the wall to the other people and you are done with it. And then it's somebody else's problem. Even in those conditions, the actual development process doesn't change. You need to build your stuff, you need to test your stuff and verify that it works according to what you wanted. And then you go into this outer loop of the development, into the deploying, monitoring, and so on. So the point here is you cannot release anything avoiding the tests. Like you have to have the tests. And great tests improve both the feedback loops. That is essentially saying that if your tests are slow, your feedback loops will be horrible. If your tests are inefficient, your feedback that you get from the tests will not give you the signal whether your application actually works or not. Tests greatly improve your flow state because they give you the clear sense of progress. You don't have to practice test-driven development. I'm not arguing that you need to do test-driven development and write tests before writing the code. If you have the tests in the same pull request as the code that you're committing, you are doing TDD enough for me. If you write the tests before the reviewer comes to you and says, like, where are the tests? You are test-driven enough for me. So whether you write the code first or you write the tests first, like people argue and have different opinions, and different developers have different preferences in that regard. But hopefully, everyone bundles together the code that does something and the tests that both verify the code and protect others from breaking it. So it helps immensely with the flow state because it gives you a clear goal and the sense of progress. Am I doing the right thing? Am I breaking other people's code while I'm developing my feature? What do I need to fix for the particular issue? Can I reproduce it in a test? Can I fix it? It gives you the path forward, and it also reduces the cognitive load a lot because you don't always have to remember what exactly you are trying to achieve. Once you encode that in a test, you can basically sort of work to just see that green check mark, and only after that you can just repeat the process of understanding whether that is enough to cover all the cases or whether the business logic requires something else. So if you have the tests that you love working with, you will improve on all three dimensions, and your developer productivity will greatly improve. There is also one conjecture that I'm not 100% sure is in. It feels that way, but I didn't talk about it with enough people to kind of sort of claim it as if it's the truth. But I think, and I want you to think about this as well, while like in this session or maybe even further, and then talk to me, find me or talk to me online or something. If you have bad tests, if you have tests that you don't like working with, you and your team in general, nothing else in your project that you are doing will help with your developer productivity. I think this is true. So from there, the answer is, of course, to improve developer productivity, you need to improve your tests, and everything else is secondary, which is a little bit ambitious. That's why I'm not 100% sure in this, because it feels awfully convenient for me. But I think that if your test suites are bad, if they are slow, if they break all the time, if you don't trust them, then this is the thing that you need to fix. And fixing other things, like making code reviews more efficient, or mastering your IDE, or any sort of other things, or restructuring your projects to have a better architecture, will not help with your developer productivity and happiness, or will not help drastically, because you will stumble upon the tests which you cannot avoid, and it will feel like a chore every time, and you will hate them, and you will hate other people on the team for not writing good tests, and it will, like, the general happiness will be low, morale will be low, and the productivity will also be low. So that is that. Let's think about that just in the background. What does it mean to have bad tests? What means, like, what are some anti-patterns that we know and very often find in the projects that clearly break the assumptions of what the good tests are? The tests that you cannot run locally. It's a clear symptom that you can improve your developer velocity very, very much if you make your system be able to be tested locally on developer machine. The ultimate source of truth is your CI environment, because that's where the automated checks happen for all the people on the team, not just you. But if you cannot run things locally, you will have to implement the changes locally, and you will commit them, and you will wait for the CI to run, and that will greatly slow down your feedback loops. Very often, teams come to us, and then when we talk about test containers, and they say, like, why do I need to run tests locally? I just commit my code, and then CI runs, and I get my answer whether this is good or bad. And I ask them, like, well, how long does it take to get the answer whether you did the right thing or not? And the normal, typical answer is like, oh yeah, you just get the answer tomorrow. And my question is, which I don't always ask because it feels maybe a little bit too on the nose. What do you do until tomorrow as a developer? If you fix something in the middle of the day, do you take half the day off? Do you go and improve documentation? Do you read your corporate wiki? Do you do, like, mandatory compliance training? Or as a developer, you want to be developing things. That's where you bring the most value. So waiting and doing other things is counterproductive. So waiting for the CI is an anti-pattern and something that you want to improve, definitely. Tests that break on changes, when you refactor something insignificant, or you change some method names or something, tests break for no apparent reason. When you change something in the domain, in the, like, logic of the application, it is natural for the test to break because they probably verified the previous behavior, and now you change something significant. When you change some small implementation details without changing the domain or business logic, tests that break is a clear sign that something is wrong. It very often happens when you tie your test implementation to your actual business application implementation too much. If you, for example, need to mock external systems very much, or components in your application, and then on every, I don't know, refactoring of the method structure that you need to run, you need to change the mocks, you need to change them in a number of places, and that is awfully counterproductive because you want to that your tests to give you these signals only when your application is actually in a broken state, if it doesn't work according to the business logic. So the answer to that is probably to have higher level tests that are less coupled to the actual implementation details. Flaky runs, if your tests always break on Tuesdays, this is not great for obvious reasons, because you cannot trust those tests. And you just rerun and rerun your CI pipelines until they sort of show you the green checkbox, which is ridiculous. Because if you know that you're going to rerun your tests until they show you green, you might as well not run them, because you're just wasting time waiting for the green checkbox. This is that example of inefficient feedback loop where you don't actually take the signal into account. And of course, if your test pipelines run awfully slowly, then this is bad for your feedback loop, for your cognitive load, and for your flow state immersion, because you just have to waste a lot of time to run this. And this is interesting because the slowness of pipelines is clearly different between your local environment and between your CI. Something that runs in CI can take, like, for example, minutes or like dozens of minutes, and it could be fine. If you need to wait locally to run some tests even for like a couple of minutes, that is awfully inefficient because your development loop in your development environment tends to be much, much quicker than the loop that goes through CI. So slow pipelines, bad. What are the good things with the tests? What should be, like, when you think about the tests, what should good tests look like? And they should look like a little bit like academic work. Not in the sense that it needs to use like complex words and be written in a latex or something, but it needs to have, the tests need to have like 3 qualities. Every test should be novel, in a sense that every test should test a particular part of functionality that is hopefully new compared to what other tests are verifying. If you run different tests that verify the same piece of functionality, the same thing, the same conditions, the same inputs, and verify the same outputs, it is inefficient. You are just wasting time. Your tests need to be reproducible, just like an academic paper or scientific breakthroughs, in the sense that you want everyone on your team be able to run the tests and get the same results. You want your CI runs have the same results that you have locally, and hopefully you want your tests to give you a significant signal in both directions. When your pipelines are red, it means, it should mean, it has to mean, it must mean that your application is broken. You don't want to have random broken builds when nothing is actually broken. But it's also very significant in the other direction. When your pipelines are green, what ideally it should tell you is that your application is of a good quality, that that commit can go and nothing is broken, or at least nothing significant is broken. So you need to be able to trust your tests to find the issues. Because if you don't trust your tests to find the issues, and you run your test and it's green, but you still don't feel confident enough in your code, and you need some other checks, then what good are those tests? Not very good. How many of you trust your tests? Like when the pipelines are green, you are like, yeah, I can deploy, nothing will break. Okay, approximately maybe like 1/3, a little bit less. So how often your stuff breaks in production anyway? Then you cannot answer with the hand to the question of how often, but does it break anyway? Yes, it breaks anyway. Very good. So much for tests. You cannot avoid this, actually. So I'm not arguing that you can build your test pipelines in a way that they will never break in production. You still need to sort of test in production, but hopefully you can move fast or slow with any speed, preferably fast, and you hopefully should know the things that you're breaking or the things that can potentially break. So the tests need to be reproducible. So how do you do tests? This is the good question. Usually, very often, people do tests like this. They start approaching a new functionality, and then what they have is usually there is a testing pyramid, right? So this is what we call a testing Dorito. This is going from planned tests into the actual tests. So at the top, you have the grand idea and the vision of the test you plan to write. And then of course, you don't write all of them, but you start writing some tests, and there are fewer of them. And then you realize that you don't like writing tests because they break, and it takes more time that actually will take to deliver the functionality. So you delete some of the tests that you started writing. And then there are actually like a subset of tests that you run in the end. So it's a clear funnel from the grand vision to the actual implementation of the tests. And of course, this is sort of a funny joke on the testing pyramid, which essentially told us in the past that you have to have a lot of unit tests, which is the implementation detail tests that would cover all possible cases, test everything in isolation, small components, maybe a few classes, maybe a few methods, maybe a class in the library calls, but in isolation. And you can run them fast, you can run them locally, and that would be the base of your test suites. And then you'll have the integration test on top of that, which will test different components together with applications. And then you'll have some of the end-to-end tests, very few of them, because they're hard to maintain and slow to run, and they break, and nobody likes them. And that was in the past, and more recently, in the recent years, especially with the move to like sort of microservices, or just in the systems where part of the logic is encoded in how different services talk to each other. Teams have realized that the integration tests are actually more important than unit tests, and they probably should be the bulk of your test suite. So the importance of the integration tests and the amount of the integration tests grows, and you still do like unit tests and implementation detail tests, but only for the business logic that actually is complex. If your application passes the data back and forth, and it needs to work with some third-party API or some other services that you develop in-house, but it actually doesn't implement anything complex, then the implementation details checks will still be covered when you run integration tests, right? You actually run your application, so you verify that it does the necessary things with the data, but you don't try to cover everything with unit tests, because that's the way pass into nowhere. Right, and you still have the integrated tests, which are tests in like environments similar to production, so sort of like a staging-like environment, but you run them fewer than the integration tests, and the integration tests are the bulk of your test suite that allow you to make the automatic decisions about the quality of your applications. So how do you do integration tests? Over the years, we kind of changed how we run them locally, and we run them in the CI pipelines. And many years back, sort of the understanding was that when you want to test different components in your application, you mock all the necessary parts, all the third-party services if you need to, and you run your tests, and the code paths that require external environment or that require complex setups, which you don't actually test in the particular use case, are mocked out, and you don't care about those. This is not great, because you're actually changing your application logic, even if in some insignificant ways. And you need to worry about the mock compatibility with the actual things. And we moved from there fairly quickly, from all sorts of embedded solutions for databases and or embedded solutions for other technologies to the local setups, where you would run the necessary technologies for your application locally. Then that is error-prone, that is not efficient with multiple projects, so we started isolating the whole environment with things like virtual machines, or with things like vagrant configuration, where you would have the configuration file that describes your whole development environment. For younger developers who didn't practice the craft at the times of Vagrant being popular, think about this as sort of the dev container definition. Now we use the same, but like we just run them in the cloud with the cloud IDs and such. But in the past, we run the same, but on your local machine. And everything would be in that virtual machine definition, both your application, your IDE, your configuration, your dependencies that you need to run your application, all will be in that environment, which is very inefficient because you have your local machine, and it's a powerful machine, and it's yours. You know how to handle this. You honed it and perfected the setup that works for you for years. So running like a separate environment within this, especially sharing it with the whole team, is inefficient. So the next step was, of course, when Docker came in, and then we started isolating only the sort of external parts of the application. We would have our application locally, we would have our tools like IDE and whatever command line tools locally, and only the third-party services that we need to run will be containerized and put in a Docker. Only third-party services like databases or, I don't know, Elasticsearch clusters would be running in the containers. So it's a split between the local tooling and the necessary components. And then the Docker Compose allowed us to provide the declarative configuration for all these third-party services that our applications do need. And it was a static configuration, and it was a game changer at the time because it allowed us much, much easier encapsulate what our application needs, like the environment for the application to run, and decouple it from the environment where we need to develop the application and the tools. And then now we go into an even more flexible approach where we use the Docker API directly, or could be any like sort of container API, but in my case, that would be the Docker API directly, and programmatically create the environments for our applications, which is, you can think of this as your code declaring what your application needs to run the tests or to run locally. And it needs three things. It needs to take care of the life cycle and the cleanup of the service dependencies that your application needs to run, like your database and so on. It needs to take care of the configuration of those applications within the containers, and it needs to take care of the integration with your frameworks or with your test libraries. So it could have been like a JUnit rule or your test library rule where you could programmatically create that environment. And, well, it was an idea many years ago, and then eventually it was superseded by test containers, and even the original author of that idea was like, yeah, okay, test containers is a better choice for this. So what is test containers? It's a collection of libraries, open source libraries, that allow you to, gives you programmatic access and programmatic API to manage all kinds of services in Docker containers. You can create the services, you can configure them, you can manage them, you can query information about them, you can copy and execute, you can execute commands, you can copy files. The whole kind of sort of surface of what you can do with containers is encapsulated in the programmatic API in your favorite language, which for a Java conference is mostly Java, or other JVM languages, which can naturally use Java libraries. But test containers also exist in other languages. We have implementations for Go, .NET, Node.js, Haskell, Rust. Recently, there was a test containers Ruby implementation created. So other languages implement this as well. So if you have colleagues who are less fortunate and don't get to develop things in Java, they can also use the test containers approach. So what test containers gives you is the API, and you can run all sorts of things. But what it also gives you is the ecosystem of modules, which give you a one-line abstractions, which you can use to create the predefined services that everyone uses very, very naturally. So you can say in one line of code, you can say, I want my Kafka container, or I want my RabbitMQ container, or I want my local stack container, which is the a mock and emulator for AWS technologies, and so on. Modules are an essential abstraction, and it allows you to decouple as a developer the kind of knowledge that you need to run those technologies from the end user, which is where you just need to use them without knowing how to run them in containers. So in my personal opinion, modules are what made test containers so popular. I think we currently have more than 50 technologies supported out of the box. You can find them on a little sort of marketplace and see which languages support which modules and so on. And recently, Atomic Jar, as the company behind test containers, we also started the official modules program where the vendors behind certain technologies support and maintain the implementation of the modules. There are not very many of them as of yet. The more of them are coming. But this is a very interesting step forward is where the vendors of databases or technologies say that test containers is the way to test applications that use their technology and support the actual implementation of the module for them. So, which is a very significant shift in the mind space, how to test applications. Right. So, why test containers are great? There are a number of features that allow test containers to shine. Why is it better than static configuration? So this is both the flexibility, it's all in the code, so you can build any sort of lifecycle systems. You can isolate environments per every test or per collection of tests. So you have the full control over how isolated your environments are versus how often you need to recreate them. And you as a developer can pick the balance. With a static configuration, you have no balance. You get one environment, whether it's local or whether it's in your CI provided by your CI platform. And if you break it, it's done. And with the tests, you want to break your environment. You want to put your application in stressful conditions where you don't actually maybe even know what will happen. For example, what will happen if your database schema is wrong or if your data is corrupted. You need to test those things. And to test those things, preferably you have isolated environments. And if you only have a single environment, then you break it, you're done. So it's hard to run tests. The flexible programmatic approach allows you to isolate things and say like, oh, you are naughty tests trying to break the environment, you get the special one. Test containers implementations are capable of abstractions, the modules system, and there is anything that you can do with the topology of the environments. You can create complex networks, you can bind services together, you can do like chaos engineering things. Every configuration is dynamic, so everything is kind of sort of you are nudged into the right implementation to allow parallelization, which will speed up things. But in a nutshell, the one sentiment why test containers tests are great is just because they feel like a unit test and they are giving you high confidence signal because they run like an integration test. Your application works with an actual real technologies. This is going to use in production. You can create any data that you would like programmatically, and you can still run your tests from the IDE. You can use the full power of your development environment, but you get good results. So that is important. And then you also get the thing that is called environmental parity, which is very often is referred as the DevProd parity. And this is one of the factors in the 12-factor applications, which is where ideally your development environment mimics your production environment to the best of its ability, because then you can trust that things in production will break the same way as they are breaking in development. So, which is very, very important. And normally, the DevProd parity is sort of how it's presented, but also what's very important, especially in the case when we talk about the testing our applications, is that there is one more environment. There is the CI where you want to run your tests. And ideally, your production is mimicked by your CI environment to the best to its ability. And then things break in production only if they were broken in CI. And then also, there is this other comparison, is that your development environment should be as close to your CI environment as possible. So if stuff breaks on CI, you can very easily reproduce it locally. And of course, you cannot get 100% reproducibility because you still need to maybe mock some network services, or you still need to use a different configuration, minimally different configuration for tests. But remember, reproducibility is a spectrum, and you just want to make as much effort, well, as little effort for as much return on your time investment as possible. So reproducibility is also always sort of a trade-off between eliminating certain classes of bugs and issues and the complexity of the system and developer velocity. You probably don't want to get like 100% code coverage for most projects. You probably don't want to fully reproduce your production environment. You very often cannot fully reproduce your production environment in development. Well, if your system consists of like hundreds of microservices, you might not even be able to spin it up from scratch locally. So it's a spectrum. You want to get to the certain point which gives you confidence. And I think test containers gives you a very good setup for this. So it works. It only requires a compatible Docker environment to run the containers. Your application uses the programmatic API access to the container environment, and then we can create those services for you. We will clean them up, allowing you reproducible builds, so the next time nothing is dangling and you will not connect to the old services if you don't want that explicitly. It works with all the CI pipelines, even if they already run in sort of containerized systems. You can always run either Docker and Docker setups, or you can run the test containers cloud setup, removing the containers runtime from the test environment into a dedicated isolated cloud VMs. You can parallelize things efficiently, and this is fairly easy to achieve, and it works very, very well. So I'm going to show you an example of a project which I wanted to tell you, and I'm going to show you two things. I'm going to show you how to run tests. We're going to use Test Containers Cloud, which is a service that it is currently free to try. You can, if you run Test Containers tests, you can check it out. How it works, it gives you the user space application that pretends to be a Docker environment, but when you start running Test Containers tests, it goes to the cloud and creates an isolated VM for you, which will run the containers, removing the load from your machine, allowing easier parallelization, and a number of other benefits. So I'm going to show Test Containers tests with Test Containers Cloud, and then we're going to also enable the local development environment in our Spring Boot application with test containers. So this is a new feature that came in Spring Boot 3.1, which was released 2 weeks ago. Spring Boot and test containers integration got tighter and more efficient. And well, I just want to show you an example how it can be done and what it feels to have the local development environment with test containers. Right, so I have my application here. And it's a sample Spring application. It's a Spring Boot application. It's a Spring Boot 3.1 application that we have, the new release thing. And it has the first certain things. It has the test containers libraries enabled. It has the application depends on the database, on Kafka and Redis. So it has the necessary Spring dependencies for those. For example, to use Kafka and to use Postgres driver. It has tests in it. And it also enables this particular new dependency that comes in 3.1 Spring Boot. It is the integration between Spring Boot and test containers. So how it looks like. The application is very, very simple. It binds on the some HTTP ports to listen to things, and then it uses Kafka for some business logic. It uses Redis for some other business logic, and it uses the SQL database for a third part of the business logic, which is essentially not exactly important right now what it does, but it needs all those technologies to be able to run. So I have a Spring Boot test, and I have a little test suite here, which actually is the high-level test suite. I have the functional integration tests, which would send the queries into my application and wait for the responses to come through, to go through Kafka broker, and then we wait for the data that we put into application to come from the other side. We do that a number of times. And then we have some other tests. The actuator test, so the Spring application thinks that we are good, that our database loads, and some also negative tests. So I have a bunch of tests. How do I create an environment for them? I use test containers libraries. And it gives you the API to run anything in containers. The most important one is probably generic container, which represents the service that you're going to be running, which can run anything, any Docker image that you want. So to run Redis, for example, we can just say like, oh, test containers, please run Redis, and configure that Docker image to have the ports exposed, sort of what you have when you do Docker run -p and then ports 6, like that, right? So, but we do that programmatically. And we can do anything programmatically here. So I can have the copy some files into the containers. I can override the commands. I can override the environment variables if I want. I can override the host configuration and do the limitations on the resources that it can get, so lower memory or the CPU counts. I can do anything that I can do with the Docker container from the convenience of my code. For Redis, I don't need to do very much, so I just do this. I need to start my Redis container, which we'll do in the helper method, and I need, of course, to configure my Spring application to use that particular technology. So I need to configure my application to talk to that particular Redis instance and nothing else. So we do that using the dynamic property source method, and all the properties that we put in here, they will overwrite the static configuration that we had before. What it means that I can run this, and in a similar way, I will configure my Postgres database, which comes from, like, this is not the low-level container. It actually, somebody went and implemented the Postgres container, so I can just avoid writing all this, but I get just one-line abstraction that I can use, and the utility methods to get the configuration for the database, like JDBC URL. I don't know the syntax for the JDBC URL, but luckily I don't have to, because it's all encoded in a library. And I will also run a Red Panda container, which is a Kafka implementation that is written, I think, in one of the native languages. So it starts faster. It's a single binary Kafka implementation. So it works very, very well for my tests. I will run that. It also comes from a library, so I don't need to know how to particularly run this. And I just configure my Kafka to use that Red Panda instance. So with those three things, what I can do, I can just run my tests. And then we'll run. The test containers libraries will determine what Docker environment it works with. In my case, this is the test containers cloud, this little menu icon there. It connects to the isolated VM in the cloud, and that will run my containers for me, and they will not run locally. For the first time, I will need to maybe pull the images, but test containers will naturally reuse the Docker cache. So the next runs will be faster because I don't need to pull the images again. So my tests run, it's all good, right? So this is how it feels, and this is what was in the past the configuration and the integration between Spring Boot and test containers. You would need to configure your configuration for the tests. Now, to enable the local development setup, what I can do the following thing. I can create a test configuration class that I will enable on my tests, and I will create the beans and say, for example, Postgres container, get Postgres, and I will return my configuration for the container. Now, Spring Boot 3.1 knows that if a bean is of a type of the container from test containers, it will handle the lifecycle for you. And also, with the help of a service connection annotation, it will know how to configure the application to talk to that particular service. So if the Postgres, it will configure that part automatically. So I don't need this, and I don't need deep start, and I don't need Postgres. So let me quickly create those other beans as well. So if I do another bean, and I will do service connection, and I will do public generic container get Redis, and I will do return my Redis thing. Wait. This is the generic container, so if the service connection needs a little help, so we're going to do, this is Redis, right? And then I need one bean for Red Panda. Service connection, public, Red Panda container, get Panda. And then I return whatever the configuration here was. Now, this is my test configuration. So I don't need my container configuration here. I don't need my properties to be overridden. And the only thing I need to do is I need to specify that I want the container config class as the configuration for my tests. Now what will happen, Spring will go find those beans, instantiate them, run them, and my test will use that environment setup to be run. And also what I can do, well, this will run, but just for the sake of time, I can create an entry point into my application from my test sources, a test application, and run my actual demo app, but also enable the same configuration that I use for my tests for the local environment. So, and when I run this test application from my test sources, in the test class path, I have access to my test containers libraries and everything. So it will start my application, and it will run the setup for me, and I will be able to actually send requests to my application and see the results coming on the other side with some data that we sent. So my application currently runs locally. My containers are running in the cloud, but the setup is reproducible. Now, I will commit those test classes into my repository, and everyone on the team will run the same config for the environment as me. Everyone, including the CI. That means that those tests will run the same way in CI, and if they fail, I can locally debug that. I can run the tests individually. I can put breakpoints in them. My application runs locally. I can put breakpoints into my application or any of particular logic classes. And this gives me the ultimate experience to reproduce failures locally, fix them quickly, verify the setup, and not wait for the long feedback loops. I can fix things quickly. I can add new tests quickly because my setup is reproducible and my tests are high level, so I can focus on the integration tests rather than implementation details tests for the particular pieces of logic. So I can be very outcome driven. And then that is very, very nice. And that gives me happiness. It allows me to be productive. And more importantly, it allows everyone on my team be equally productive. So this is a quick example. I just wanted to show you that if you are interested or if you want to try it, then we have the workshop about test containers usage where you can try implementing your test containers tests or go with more complex setups, try the local development environments with Spring Boot 3.1, try the chaos engineering practices, come after lunch to Room Lab 1 and bring your laptop because this is a hands-on session, so you can try that very, very nicely. Me and Peter will be happy to see you there, or your colleagues if you want to recommend it to them. And if you want more information, testcontainers.com is where you can find everything about test containers. Testcontainers.cloud if you want to try the cloud. And if you want to hang out with the community and talk to the team, please join the Slack. All kinds of questions are welcome there. And the team of the maintainers hangs out there for all the languages, not just Java. And we will be happy to see you there. Thank you very much. That was it.